3-5. And we are going to be adding and subtracting like fractions. Now, the adding and subtracting rule for integers, it just never goes away. I'm telling you, it just keeps coming. So we're going to go back to, right? We know how to add and subtract integers. What's the rule if the signs are the same when you're adding and subtracting? Somebody tell me. Yes. That's multiplication. How about when you're adding and subtracting? Gage? Yeah, but I'm just mean just the I'm not talking about fractions. I'm just talking about the general rule when you add and subtract integers. If the signs match, yes. That's if we're talking about fractions. I'm going back 4 weeks when we did the lesson on just adding and subtracting integers. -2 plus -3. Right? Negative and a negative. No, that's multiplication. I'm glad we're reviewing this. Anybody else want to take a stab at it? Yes. Yeah, you add the two numbers and keep the sign. So a +2 and a +3, they're both positive. So you add 2 plus 3. And because kind of the parent sign is positive, then the answer is positive. If you have -2 and -3, right? Think of it if you're 2 feet deep and you go 3 feet deeper, right? You still add the two numbers, 2 and 3, but because both are negative, remember your parent sign is negative, so your answer sign should be negative. That same concept applies here, but like you all, because you were on the fractions already, you're right. If your denominators are the same, which is what Jada said, was right. And then who else said add straight across? You were right there too. Who said that? Yes, you guys were right on fractions. So if you look at this first example here, 5/7 plus 2/7. The denominators are the same. So you just add across the top, right? 5 plus 2 is 7 over, keep the denominator, and then always reduce if you can. What's anything over itself? 1. Okay. So when the denominators are the same, you kind of ignore the denominator, right? The denominator just becomes the denominator of the answer. So we'll do number 3 here. And now, obviously, you won't do this on your paper, but I'm just going to do it to show you. If your denominators are the same, you can kind of, for a second, forget you're dealing with fractions. Okay, now don't do this on your paper. I'm just showing you what I'm talking about. For a second now, because your denominators are the same, forget you're dealing with fractions, and it's just simply 13 minus 3. And 13 minus 3, now, of course, we're not really forgetting, so we're going to keep them, but that was just to make a point. Do what? Yeah, 13 minus 3 is 10, and then, of course, we always simplify, if we can, 10 over 20 is 1/2. Okay. Excuse me. What if you have one like this? Okay. And if it makes it easier for you, right, get that denominator over there to begin with. And then for a second, right, even if it helps you to cover it up, cover this up for a second with your hand, if it helps you, and just look at -19 plus 21. Well, -19 and plus 21, the signs are different, which means we're going to subtract. Gage? Yep, positive or negative? +2. We subtract the two numbers, so 21 minus 19 leaves us 2, and then we look at the two numbers, and just at their absolute value, the 21 and the 19, which one is a bigger absolute value? The 21, which means it rules, right? It trumps, and we take its sign, so it's +2. And then we reduce if possible, and they both are reducible by 2, right? You can, if it helps you to write it out, they're both divisible by 2. So when we reduce that, we get 1/20. And it's positive because our bigger number at the top was positive, okay? Very similar here. Okay, again, keep your denominator, right? Keep your denominator, and then just look at, cover it with your hand if it helps, 14 minus 16. What's 14 minus 16? You got a +14 and a -16. Somebody else, who hasn't answered yet? I'm just gonna try to, I know you've already answered. All right, Zach. Okay, now positive or negative? You got 14 and 16. Which of those two are a bigger number? 16, is the 16 positive or negative? This right here. It kind of looks weird because it's down a little bit lower, but that negative still applies to that fraction. So it's 14 minus 16. Okay, if it helps you to think of it, to write it up a little bit higher, because really you're subtracting 14 minus 16. The 16 is the bigger number and it's a negative. So you'd have negative 2 over 23, and that can't be reduced. Okay, so that's a very quick review on adding and subtracting. What if you have two negatives? Cam? Did you have a question? Yeah. Okay, if I were to take out the fractions from it and I were to write 14 minus 16, which is what we got. It just kind of looks a little bit more muddier because it's in a fraction. And that's why I said, if it helps you, do this for a second, right? Put the plus sign up here and do this for a second if it helps you, because it kind of clears up what you're actually adding and subtracting. Because really you're just adding and subtracting the top. And so if you need to raise that sign up a little bit and stick it in the middle there so it looks like just a simple subtraction problem, sometimes it stands out a little bit better than, because fractions just tend to muddy the water a little bit when we're thinking about. Yep. And if you think about it, right, if you have $14 and you spend 16, right, you're $2 in the negative, overspent by $2. Yeah. Anybody else? And you can write it like this. We just don't typically. You can write 14 plus a negative 16. It's kind of a messier way to write it, but you can write it like that too. And that shows you too that the 16 is the negative. All right. When you have mixed, let's do one that's a negative and a negative if I have one. Yeah, there we go. It's the one I had up, wasn't it? Negative and a negative, right? It's a negative 7 minus a 4. Again, if it helps, put your denominator. I'm going to just raise my signs up for a second, and then I'm just going to do this for just a second, and I'll erase that. If I was to just say what's negative 7 minus 4, two negatives go deeper negative, right? So negative 7, dig 4 feet deeper. How deep are you? Somebody that hasn't answered yet? Nobody? All right, Cam. Negative 11. Can it be reduced? Nope. And again, right, on your paper, I don't care if you raise your signs up a little bit if it helps you see that it's negative 7 minus 4, but don't do this. I'm just doing this to make a point to show you on the overhead. Please don't do that on your papers and mark them all up like that. Yes. Yes. Sorry, I got distracted on erasing my own scribbles. Yes. And now it's a negative, right? So we're going to leave it a negative. 9 goes into 11 once with 2 left over, and then we keep the denominator. So there's our final answer as a mixed fraction. All right. What if you start out mixed? Can we do anything with mixed? Cam? Got to turn it improper first. 7 times 10 is 70, plus 4 is 74. And we keep the denominator. Plus 7 times 11 is 77, plus 5 is 82. Is that right? Yeah. Over 7. We have like denominators, so we simply add across the top. 74 plus 82 is 156. Keep the denominator. And now the last step, everything was positive, so we're good there. The last step is to change this into a mix. And you do that by, how many times does 7 go into 156? I don't know what, there it is. And again, right, you don't have to do mental gymnastics, get a calculator. 156 divided by 7 is 22 and something. So 22 is our whole number. And if you take 22 times 7, that tells you how many wholes you took care of, which is 154. We needed 156, so that's 2 left over, and then we keep our denominator of 7. Okay? Yes. Say that one more time. You can't, and I mean, if so, my niece showed me the way they teach them in like elementary school, and you add 10 and 11 and you get 21, and then you add 4 and 5 and you get 9/7. And so you have to convert 9/7 into another whole with a remaining 2/7. I think it's personally a little more confusing than no, I would rather you, no, I want you to do it this way. Okay. That way everybody's doing it the same. It's very simple and it's the same way every single time. Okay. Turn them into impropers, add them, turn it back to mixed. Okay. All right. So one thing I want to throw out at you really quickly is what about when you have variables? Let's do these two and then well, these two right here, and then we'll move on. 5p minus, or 5p over 9 minus 4p over 9. Don't let the variables throw you. Okay. Do you have a like denominator? Then keep it. It's that simple, right? Like denominator, you keep it. Now it's like saying 5p minus 4p, or 5 apples minus 4 apples. 1 apple or 1p. Your variable is your apple. If it helps you to say it like that, sometimes it helps you to actually think about it in concrete terms rather than variables. So 5p minus 4p is like saying I had 4 apples minus 4, or 5 apples minus 4 apples. I have 1 apple. Just make sure you write your p as your apple, okay? And again, if you want to, but you do not have to, you can clean that up by getting rid of the 1, but you don't have to. All right, so turning this into a mixed number, we still take 4 times 7. Okay, we ignore the a for a minute. That's 28. Plus 5 is 33. Okay, whoops. 33. And then just keep the same denominator like we always do, 7a. Minus 7 times 2 is 14. Plus 3 is 17. Keep the 7a. And now we're good. We have like denominators. So we keep the same denominator. And 33 minus 17. I should be able to do that to my head, but I don't. 16. And then let's turn that back into a mixed. We ignore the a for a second. Well, no. Remember when I said it's when it's variables? Don't mess with turning it back into a mixed. When you've got a variable in there, it kind of muddies the water. Just leave it improper. Okay. When you have a variable, just leave it improper. We'll kind of stay consistent with what I told you yesterday. When you have a variable, just leave it. Okay. Are we good with that? All right. I want to go over just really quickly. And I want to do a quick review on when you don't have matching denominators. So go ahead and drop down a little bit in your notes and put 3-6, because this is really tomorrow's notes, but I'm giving them to you today. Okay, I probably will not be here tomorrow. All right, so when you're just looking at a basic problem, you cannot add these together because they don't have like denominators. Yes. But it's none of it's due until Friday or until Thursday. Yeah. Kind of like we're doing a 2-day assignment. Yeah. 2-day assignment. We're taking the notes for it today. And then I'll only give you 3-5 today. The sub will give you 3-6 tomorrow, but none of it's due until Thursday. We won't go over any of it till Thursday. Yeah, you can get another piece of paper if you want. It's 3-6, sorry. And the difference is our fractions are unlike denominators. And again, I'm not going to spend a ton of time on this part because I want to do a few with variables. So go ahead and write that down. What? Adding and subtracting fractions with unlike, I think it says unlike. Yeah. Unlike fractions. There you go. Adding and subtracting with unlike fractions. We already did multiplying and dividing. We started with multiplying and dividing. The last 2 days. It doesn't, with multiplying and dividing, it doesn't matter. Remember? If you're multiplying and dividing fractions, you don't have to have a like denominator. You just cross reduce and then multiply across the top. The only time you have to worry about like denominators is when you're adding and subtracting. The rules are kind of different. That's all right. Okay, so the easiest way to make these like, okay, is to you can, well, I shouldn't say the easiest way. There's two ways to do it. One is you can find their least common multiplier, which means, can you make a 2 a 10? Okay, that's the easiest way to look at it. Look at your small one and say, can I multiply 2 times something to make it a 10? If the answer is yes, then it's a one-step change. Yes, ma'am. Yes. So if I want to ask myself, I want to make the 2 a 10 if possible, right? Because that's the easiest way to do it. To do that, I'm going to multiply that 2 by a 5, right? But I know in math, I can't just multiply this down here by a 5 because that changes the value. If I multiply both top and bottom by a 5, right? What's 5 over 5 reduced to? 1. And if I multiply 1/2 by 1, have I changed it from 1/2? I haven't broken any math rules. So my new problem is going to be 9 plus 10, or 9 over 10 plus 1 times 5, right? I'm rewriting this right here now as a new fraction. 1 times 5 is 5, and 2 times 5 is 10. Now I've got like denominators. Okay? And then I'm not going to work it past that. Looking at this one, the first thing you should ask yourself is, can I make the little one the same as the big one? If the answer is yes, it's a one-stop change, or it's a one-step change, yes. So you don't work it out? Well, yes, you do. I'm just not, because we just did notes on adding. So I'm not going to take up time on adding. I'm just going to help you with getting them alike. Once they're alike, yes, you do it just like 3, 5, which is you add or subtract. But now you have like denominators, which is your goal. So can I make a 4 a 16? All right, what do I need to multiply 4 by in order to make it a 16? Okay, if I multiply this by 4, I know I have to multiply this by 4. That's the rule, right? So let's rewrite that term that we just changed. Don't lose the negative. Negative 3 times 4 is 12. 4 times 4 is 16. I didn't mess with the other one at all, so it stays plus 5/16. I didn't change it at all. Now you're ready to go like yesterday and work it. Okay? Hopefully this is review. All right, so what about when you've got one like this one? Can I multiply 5 by anything to make it a 6? Hang on. Can I multiply 5 by anything to make it a 6? That should always be your first question. If the answer is yes, you do the one step like those two. If the answer is no, okay, it's an easy solution. You just have, it's just a 2-step instead of a 1-step. The 2 steps are, you take the 6 from the one on the right and you multiply this times 6 and this times 6. Okay, just follow me on my steps. Then on the other side of the other side, I'm going to take that 2/6 fraction and I'm going to take the denominator from the other side and I'm going to multiply these both times 5. Now it takes a minute to kind of reflesh this out and rewrite this. So in the red one, on the top, I've got 6 times 4, which is 24. And on the bottom, 6 times 5 is 30, right? Minus, because it's a minus sign right here. Now go to the purple side, and I have 2 times 5 is 10 over 6 times 5 is 30. By multiplying them by each other's denominator, I have forced them to both have a denominator of 30, okay? That's the easiest way to do it. One step, can I make one the other? So we're not going to work it out, but can I make a 3 a 36? Okay, what do I have to multiply it by? 12. That means I multiply the top by 12. So that's a nice one-step one. Can I make a 6 a 21? If I can't, it becomes a 2-step one, and I have to multiply them by each other's number. But when I do that, I have to make sure and do the same to top and bottom. You guys should have already done this, so I'm not going to spend a ton of time on this. I will put a Khan Academy video on there. It's not an assignment that's due. It's just if you need a video to kind of walk you through it again, he'll do that. And then again, same process. Okay, you've got to change. You never work with mixed. Change the mixed, then do the same process we did above. Okay, are we good there? All right, I'm going to go ahead and stop the recording. For those of you at home, if you have any questions, I will link a couple of Khan Academy videos to our Canvas homepage. so that you can watch those if you have questions. And then there is a 3-5 and 3-6, and they are both due on Thursday. Email me if you have any questions.